Welcome back to P1. Today we're looking at linear inequalities, unit 3.4. This is pretty much a GCSE or IGCSE topic, and you shouldn't have too many difficulties with this. In the most part, it's very similar to how you solve an equation. The only thing you should be careful of is if you need to multiply or divide by a negative value. But you can avoid that scenario by always taking your unknowns to the side where you have the most of them, so it's always going to stay positive in terms of the unknown or the coefficient of the unknown. If you do that, then you should negate the possibility of making an error with these. Let's look at a couple of examples then. So this first one, you're just going to approach it the same way you would approach solving an equation. You can see that I've got 8x on one side, that's my largest value of x is, largest positive. So I'm going to get rid of my x from both sides. So 7x plus 3 is greater than or equal to 24. Then I want to get rid of that positive 3. And that will then leave me with 7x is greater than or equal to 21. And then finally, dividing both sides by 7, that leaves me with x is greater than or equal to 3. And sometimes you're asked to show this on a number line. If you are, and you're doing it from scratch, just start with your answer. And then you just need to do a circle, and if it's also equal, you want to colour the circle in, and then it's greater than, we want greater than, so we're looking in this direction, and I'm just putting an arrow on the end then to show that it is all those values that are greater than or equal to 3. Okay, part B, first thing I want to do is expand my brackets. And then I'm going to do this a bit quicker this time. So I'm going to get x on the right, minus 3 on the left there. So I'm taking away 2x first and then adding 3. And there's my answer. Now, I generally prefer to write it with the x first, so x is less than minus 3. So again, if you need to show this on a number line, just start with your actual value in the middle. Then I want to circle, and then it's less than, so it's going to go in this direction. Now notice this time I'm not colouring in the circle. The circle here is hollow, and it's hollow because it's not equal to the 3. Okay, it's everything less than 3 but not the 3. And that's the first example done. Now let's look what happens when I'm looking at two inequalities together. So my first step is to solve them. So we've already done these two, but I will do it again quite quickly. That was our first one, and then if you remember, our second one looked very much like this. Now let's look at it on a number line. 2, 3. So greater than or equal to 3. And less than negative 3. That's what we're looking at. There's no overlap between these two. Okay. So my solution should be written as x is greater than or equal to 3 or x is less than minus 3. Alternatively, in set notation, this could be written as x is less than negative 3 union, and x is greater than or equal to 3. And this is how I would write it in set notation. And those of you who remember probability and things, union is just essentially, when you think about it, is when you're talking about or something happening, this or this. Let's look at another example. So again, I'm going to solve these quite quickly. And when I'm looking at this one, so we've got x is less than 4, x is greater than 12. I'm just going to go in twos here so I can fit it all in nicely. So greater than negative 12 means I'm looking in this direction. Now I'll do the other one in black so you can see, but less than 4 is then in this direction. Now what works for both of them, well, it should be obvious, but what works for both of them is between these two blue lines. So we're actually looking at when x is less than 4 but greater than negative 12. Okay, so very straightforward that. And in set notation you can write it pretty much the same way. This could also be written as using the intersection sign. Like so. Okay, so this is an alternative way of writing that one, remembering that we're basically looking at and for this one. When you're thinking of and this has to happen, intersection. If it's or this has to happen, is union. Okay, and those are there just in case you get asked to write your answer in set notation. So as you can see here, the only thing that works is greater than this value here. So my final answer is greater than 5/2. And in set notation, we would write x such that x is greater than 5/2. And the bracket is just there to denote our set, just a set. Okay. Okay, let's do this one together quickly. So expand my brackets. Take my x's over to one side, so add 2x, then take away the 15. Gives me my first answer. Second one I'll do in black, so expand my brackets. And largest x is on the left, so take away 12x and then add 5. So here we get x is greater than 8. So we got x is less than 7, x is greater than 8. Now x less than 7 will look like this. So a hollow circle and my arrow going less than, and x is greater than 8. Again, it's a hollow circle, and then we're looking at the arrow going upwards, greater than. So this means we've got x is less than 7 or x is greater than 8. So in set notation, that is x such that x is less than 7, or, which is our union, x such that x is greater than 8. And then in separate brackets, because they are separate sets, there's no overlap here, so they should be kept separate. Okay, I have seen in the past people write something like this, where x is greater than 8 and x is less than 7. Okay, but you shouldn't do that, because this is greater than 8 and less than 7. It's not a single set as it is. It's not an overlapping set of numbers, so they should be written separately. Hopefully you found the video useful. Please like and subscribe, and feel free to put some messages in the comments for me if there's anything you want to see in particular. If you think that there's more you want to see within my videos, or there's things that you want me to cut out, just put it in the comments. All your feedback is welcome. Thank you, and see you in the next video, which will be solving quadratic inequalities.